Alright, today I'm going to show you how to convert the output of a 240 volt PIP transformer to split phase, because they don't have split phase. And that's going to be for this ST series transformer, ST5000 in this case. But as long as it's an ST series transformer and it has the toroidal transformer inside of it, it'll be the same for pretty much all of them, just different sizes. Now the thing on these is whenever you get the power commercially through a power company, the power that you get comes through a transformer at the street, generally on a typical grid connected home. And it could be from the alley with a transformer mounted on a pole that supplies anywhere from 2 to 6 houses, to one that's on the ground that's one of those metal box looking things, and it'll supply 2 to 6 houses as well. This is the same thing, it's just a much smaller scale to just power your small home or cabin or whatever. But this will show you how to get split phase power out of a single phase MPPT or MPP Solar PIP inverter, and happy to have you along as usual. Okay, so you got to start out by taking all the screws out of the housing. Looks like that they've put different screws in this thing, because these don't at all look like the original screws that I normally see in these. Generally, they've got black screws in them that pretty well match the case, and that's not the case here. I do want to say that if you don't have any electrical experience at all, and you don't have any idea the difference between single phase and split phase and 3-phase and all that kind of stuff, then you probably want to get somebody that knows about electricity to do this for you, just as a safety thing, because if you do get something backwards, you can short things out, and certainly the breakers should keep everything from going really bad haywire, but still, it's better to have things done properly. So if you're not sure, just hire somebody or get a good friend that knows a lot about electricity to help you. And there's the inside of the transformer. Not a lot to it, but that's it. And this is the toroid part of the transformer, toroid. And then of course you have the safety devices in here, the breakers and that kind of stuff, pilot light. And then you can see here that you have one wire coming in and one other wire going in at the bottom. So these actually go into the PIP inverter, and they also go out to your breaker panel. This is the center tap of the transformer, because it has 2 wires that you can see here that go in. So this is the center of the transformer. This gives your split of the phase. This also becomes neutral. Alright, I'm going to give a little bit of a close-up here so you can see better. But right here you see that you have this one lone wire going into the transformer. Down here you have one lone wire going into the transformer. And then up here you can see there's, let me get something to point here, use my screwdriver. You can see this wire right here, and also this wire right here. These wires are from the center of the transformer. This is your center tap. This is what gives you your neutral or your split phase out of this thing. So this becomes your neutral, it's grounded, These two legs here go to the PIP inverter. They also go to the hot legs of your breaker panel, and then this goes to the neutral in your breaker panel. It's very easy to do. A lot of people really complicate these things, and it's not complicated at all. Just threads are a little bit tight. They might have screwed it in to get it in. There it goes. All right. Now, so that I can use the existing safety that's in here, this input breaker as well as this on-off safety switch here. So I'm going to continue to use these safety switches, this safety breaker and this on-off switch here that I believe is also a breaker. If not, it's a real fancy switch. And because I want to continue to use those safety items, I'm going to keep part of this cable, not a lot of it. And the rest of it we're just going to throw away because it's not needed. And then I'm going to pull the wires out of the sleeve here. Alright, so I'm going to continue to use this black wire and this white wire. And what I'm going to have to tap into is I'm going to need to tap into this center tap right here. So I've got to take that apart. Alright, so this wire comes off of the center tap on this transformer over here. So this comes around to this yellow wire to this outlet down here, and then this wire came up to that. Now it also went over to a 110 volt circuit breaker that was in this hole, and we don't need that because that's if you're using the 110 volts as input. We're never going to do that in this scenario. So I've just simply removed it, and then we'll connect the neutral to this wire, and then our two hots are going to go, one of them will go to this white wire, and then the other one will go to this black wire. So that's our two loads, two line inputs, and our neutral. Very easy to do in these transformers. Okay, and then I bought these stepper bits at Home Depot. You can see here it says step bit. And you open this up, and then you've got regular metal drill bits here. And then you've got these two cone bits, which are called stepper bits. And I use these to make these holes here. Use that to make these holes bigger. So I've got this one right here, and that's going to fit into that hole without any problem at all. But this hole, that one needs to be made a little bit bigger. So we're going to do that. more step. You don't want to make it too big, because if you do, it's hard to undo a hole. And there it is. Now we're going to shake out all these metal shavings. Make sure there's none left. Okay. What I'm going to do here is, because right here I've got this label that says AC 110, 120, I'm going to have my split phase go through that, since the split phase has the 110, 120 voltage going through it. I'm going to need that little eyelet thing anymore. Now, I usually use these little tan wire nuts here to make my wire connections. You can see here that it's good for up to 3 10-gauge connections. We're only going to make 2 10-gauge plus maybe 1 14-gauge, except in the case of the ground, which would be about an 18-gauge, maybe a 16. And I use all 10-gauge wire for my connections. Now, for the one from the PIP inverters, I'm going to use NMB-2, which basically means I've got 2 conductors plus a ground here. So this is going to be coming from the inverters. It's going to be coming from the inverters into the transformer. Okay, this wire this is NM-B 3 conductor. So it's got 3 conductors with a ground. These two, the red and the black, will be hots, and the white will be neutral. On this guy, the white and black will be hots, but the white will just connect where this red wire connects. Okay, I got to thinking that there might be some people wondering how I come off of this center tap here out of this transformer, and you can see that this yellow wire right here goes down to this plug or this outlet here, and several wires come off of that, and those are all neutral. Well, this one right here is the one that I've tapped into. I cut it off because it did go to another breaker that was down here, so if you use this box for 110 volt out or input and step up to 220 volts output, that's what this breaker protected. Well, since we're never going to have that scenario, I've got it wired so that that's not even used, but the wire that I cut out of that is the neutral for this, so that's what I'm using. Alright, so now what I'm going to do is I'm going to tie all of these grounds together, but first I'm going to take this ground and I'm going to loop it through this bolt right here and tighten it into that, and then that's going to be the ground for everything at that point. So I'm basically going to turn that into a ground. This thing centered back again. Okay. Okay, that looks good. Then I'm going to take this ground, I'm going to thread home through here. And normally I'd use a socket for this, but I don't want to go have to get my socket set right now. Okay, now we're going to get all these grounds hooked together. So these two guys. Alright, so this one, let's get our neutral hooked up. So that goes into this top cable where the red and black wires come out of. So on this one, we're going to have this white wire hook up to this white wire and this red wire. And then this black wire will hook up to all the black wires. Okay. Because this red is going to go to the service panel. This white from the bottom cable that's only 2 conductors. This white goes to the PIP inverter. And we'll just tuck that guy that direction. And there it is, all done. Wired up and ready to be wired into the system. Okay. I've got the transformer brought into the house and I've run it up to this panel. This panel only has 220. It does not have 110 in it because it runs directly off of this PIP inverter, and that only runs the water heater and the car charger. So I'm going to switch over to this phone camera here and show that this right here, these 2 wires, you can see this is the NM-B 2 conductor. I've got the ground going to the ground, and then the white and the black going to this breaker, and it is on. And then the switch on the back of this transformer is off. And then I've got the output with just bare wires up here, and we're going to look at the voltage on this here shortly. So I'm going to turn this on now, and you can see the little red light has come on. And I'm going to grab this camera and we'll come up close here. and hopefully everybody will be able to see this okay. And these leads are all hot. So there's our 110 volt leg, shows 108. This meter is not an RMS meter. So from either leg we've got 108 volts. And that's nice. And then between the two legs we have 220. So there you have it. And then to make sure that this thing does work, I've got this Ryobi reciprocating saw. That outlet works. So all the outlets on this work as they originally did, and it's ready to go. Wire in.